Hey guys, we're starting Unit 4, Mass, Temperature, and Volume. Now, before I get into the notes a bit, I just want to give you a really quick history of temperature scales and thermometers. So the first thermometers couldn't actually measure, so thermometer, you can measure something, what the temperature was, but you could tell whether the temperature was rising or falling. So they were called thermoscopes. The reason that they couldn't measure how many degrees was because people hadn't invented what a degree was yet, and we'll get to that in a second. So basically, what they were, you might see them around in houses. This is a thermoscope, and all of these bulbs have varying masses inside of them. Now, when the temperature rises, bulbs will sink because the water becomes less dense, and so these will sink to the bottom because they won't float as well. And then as the temperature falls, you'd have bulbs rising to the top because the water gets more dense. So you could tell when temperature was rising or falling, but not by how much. So Galileo Galilei was the guy who invented this in 1593, and it took a couple hundred years before somebody figured out a way to put that into a number, like how much is the temperature rising or falling, instead of just seeing whether it was warmer or colder. Now, that person was Daniel Gabriel Fahrenheit, and he did that in 1714. So he was a German physicist, and he took a very thin cylinder, he filled it with mercury, he closed it up, because you don't want to touch mercury because it'll go insane, and he is like, okay, 0, I'm gonna put a 0 and 100 on here, and what I'm gonna say is 0 is when I'm gonna put my thermometer that I've just made into this brine of like salt and water and ice, and that's going to be 0 degrees, sorry, not Celsius, Fahrenheit. Okay, so that's 0 Fahrenheit. And then he's like, well, what do I want 100 to be? You know what? It should be human body temperature. So 100 Fahrenheit is going to be human body temperature. And so the legend goes that he took his thermometer and put it under his wife's armpit and was like, okay. And wherever it rose, he's like, all right, that is human body temperature, and that is 100 degrees Fahrenheit. Now, with the advances in thermometers, now human body temperature is not, it doesn't go all the way up to 100 degrees Fahrenheit, so the thermometers have gotten a little better. Human body temperature is actually about 98.6 or 98.7 Fahrenheit, but close enough. Okay, so Anders Celsius was a scientist, and you'll recognize Celsius because it's our Celsius scale. And he was like, okay, I appreciate what you have done, Fahrenheit, with making temperature quantifiable. Like I can actually say what temperature it is, but I don't like what you used as 0 and 100. So he did the same thing. He took a mercury-filled thermometer, and he's like, okay, this 0 is going to be when water freezes. Okay, so water is very important with everything we do. Very important in the scientific fields. Very important in just human life. Boiling water for drinking or eating. So very important. So freezing, 0 degrees Celsius, and water boiling is going to be 100 degrees Celsius. So he's like, water, very important. We're going to use that for our scale. So 0 degrees Celsius is when water freezes, 100 is when it boils, and we make 100 ticks in there, and that is, each tick is 1 degree Celsius. So Fahrenheit did the same thing. So from his 0 briny water to human body temperature, he made 100 ticks, and each of those is 1 degrees Fahrenheit. Okay, but they are not going to be the same. So 1 degrees Fahrenheit does not equal 1 degree Celsius. Okay, so Lord Kelvin, you might not recognize this, but his temperature scale is, or his temperature unit is kelvins, and you'll see this in most often science. And he's like, okay, Celsius, Anders, I like how you use water, like that appeals to me. So 1 degree Celsius is going to be 1 degree Kelvin, but I want that 0 to actually mean something. So his 0 degree, or not degrees, it's just 0 Kelvin, is the coldest, absolute coldest that anything can ever get. So you can't get any colder than 0 Kelvin, and that's at about negative 273 degrees Celsius. You can't actually get any colder than this. It is scientifically impossible. Okay, so 0 Kelvin is as as cold as possible as it can ever get. So that's what 0 means. No more heat can be lost at 0. Okay. You will not use this very much. We talk about it a little bit next year if you take physical science, but other than that, you're good. Now, comparing those, so degrees Celsius and Fahrenheit. Degrees Celsius and Fahrenheit actually have the same value when it's -40. So at -40 Celsius, it's actually -40 Fahrenheit, but that's the only time that they're ever the same. Okay, so remember, water freezes at 0 Celsius, it freezes at 32 Fahrenheit. So if you're in the States and it's going to be below 32 or around 32, you'd want to watch out on the roads if you were driving, right? Because it'd be freezing. But we're just used to that. As long as it's around 0, we know there, if we were traveling, we'd have to be, okay, 32 Fahrenheit. All right, I'll have to be careful on the roads tomorrow morning. Okay, 100 degrees Celsius, when water boils, that is 212 degrees Fahrenheit. Okay. So they are going to be different values unless it's -40 out. All right, so traveling in the States, they use the Fahrenheit scale. So in the imperial system, the units for temperature are Fahrenheit. Canada, of course, uses Celsius scale. Oops, I spelled that wrong. Celsius, that's an S. Unless you are a little bit older, you'll still hear people in Canada using the Fahrenheit scale because they grew up on it, because we didn't change into the metric system till a little bit later. So from our previous page, we know water freezes at 0 degrees Celsius and boils at 100 degrees Celsius because that is how the Celsius scale was made. Actually made because of the freezing and boiling point of water, so 0 and 100, not a coincidence. So on the Fahrenheit scale, water freezes at 32 degrees Fahrenheit and boils at 212. Now, how we can get from, okay, knowing what something is in Celsius to what it is in Fahrenheit is using these two formulas. Now, I know some people do not like fractions, just absolutely loathe them. So we're going to come up with two formulas that don't have the fraction in them. So for those of you who the fraction is just that one extra little bit of confusing thing you have to deal with, you can use the decimal ones. But I am going to use a fraction one for first. Okay, so for Celsius equals, this is when we are given Fahrenheit and we want to find Celsius. We use the C equals. And the F equals is when we want to find out what it is in Fahrenheit. Now, let's take this 34 degrees Celsius and convert it to Fahrenheit. So 34 degrees Celsius, and I want to find what it is in Fahrenheit, I will have to use an F equals. So F equals 9/5 Celsius plus 32. Now, it's going to be important to use order of operations or BEDMAS for these. Okay, remember brackets first, exponents, and then division, multiplication, then addition and subtraction. So because we do have a formula with brackets, but it's not this one. So here, substitute our 34 Celsius in for C. So we get 9/5 and 34 plus 32. And what we have to do first is this 9 divided by 5 and then times 34. So 9 divided by 5 times 34. It's not really going to matter which one you do first, 9 times 34 or 9 divided by 5 times 34. But let's actually do 9 divided by 5 first. Okay, so when I do 9 divided by 5 first, I get 1.8. Then I'll times that by 34. And you get 61.2. Okay, so then I take my 61.2. Now I can add that to 32. And we get 93.2. And that is, we've just turned it into degrees Fahrenheit. Now, for the next one, I want us to look at this this part right here, this 1.8, how we got that. So let's say I really don't like using this 9 divided by 5 in there, because I'm like, well, what do I do? Do I do 9 divided by 5 and multiply by 34? Like, do I do 9 times 34 divided by 5? Some people will just randomly get these mixed up and it'll confuse them, and it's just from not dealing with fractions very much maybe, but let's say we didn't want to use fractions, they were just confusing us. So we could look at what 9 divided by 5 actually is, because that's something that is the same in all of our questions. So we always have to do a 9 divided by 5 when I'm turning Celsius into Fahrenheit. So if I do 9 divided by 5, I see that I get that 1.8. So actually I could take this and make it into my formula. So instead of doing that 9 divided by 5 all the time, I could just say, well, 9 divided by 5, that's a number, that's exactly 1.8. So 1.8 times whatever I had in Celsius plus 32. So for those of you who just do not like dealing with fractions, put this onto your formula page in your book. So Fahrenheit equals 1.8 Celsius plus 32. So you've already done the first step. You've done that 9 divided by 5 already. Okay, so this can be your new formula. So you can get that on your page. So let's use that, the formula that we have just made by just doing this first step, that 9 divided by 5. Okay, so turning negative degrees Celsius into Fahrenheit. So have to use a Fahrenheit equals. So Fahrenheit equals, and then let's use 1.8 C plus 32. So 1.8 and then negative 20 plus 32. Now taking a look here, brackets, nothing to do inside them. Next, exponents, there is none. Division and multiplication. So I will have to do my 1.8 times negative 20 before I can add. So that step first. So 1.8 times negative 20, and I get negative 36. So one way I can read this is, okay, let's say it's negative 36, so it's super cold, and it's getting 32 degrees warmer. So I'm going up 32 degrees, and I would land at negative 4. So negative 4 degrees Fahrenheit. So convert the following temperatures to degrees Celsius. So 80 degrees Fahrenheit. While taking a look above, I'm turning a Fahrenheit into Celsius, so I need a C equals. So C equals 5/9 times Fahrenheit minus 32. Yes, okay. So substituting in for the Fahrenheit. So 5/9 times my Fahrenheit, which is 80, minus 32. And for this one, we need to do inside of our brackets first before we deal with this fraction outside. So inside my brackets, I have to do 80 minus 32 first. So 80 minus 32 is 48. Now let's do the same thing as last time. So I'm just going to continue working up here. Equals 5 divided by 9. You get 0.555 repeating, so this repeats. Then you multiply that by 48. So 0.555 blah, 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 times 48. And you get 26.6 repeating. So that goes on. Now let's just round that to 1 decimal place. So 1 decimal place, that's where we'll cut it off, take a peek over the wall, and we do have to round it up. So 26.7, and then we change that Fahrenheit into degrees Celsius. So if someone tells you it's 80 Fahrenheit, that is 26.7 degrees Celsius. Now for the next one, we are going to figure out that first, or that one step where we're doing 5 divided by 9, because since we have to do that every time, we can just turn that into a decimal and put that into our equation. Now, 5 divided by 9 is not going to be as nice as 9 divided by 5, because 9 divided by 5 was exactly 1.8, and 5 divided by 9 is 0.5 repeating, so 0.5555555. So anytime we're going to cut that off, we are going to have an estimated answer, not an exact answer. So when you are converting into Celsius, and if you use the decimal instead of the fraction, you might have a decimal place or two off. Okay, so don't be alarmed if your answer is supposed to be 18.2 and you get like 18.4 or something. That's just from using that rounded answer. So when I do 5 divided by 9, so this part right here, 5 divided by 9, I get 0.55555. So let's cut it off at 3 decimal places because that should be accurate enough. So 0.55, and if I'm cutting it off at 3 decimal places, the number is actually keeps going and going and going. If I cut it off and I round it, I'm going to have to round that last 5 up. So 0.556, and then times Fahrenheit minus 32. So you can get this right onto your book there, on your formula page, or in your student just notes pages in your book. So 0.556 times Fahrenheit minus 32. And so for our last example, we are going to use that 0.556 Fahrenheit minus 32 instead of the fractional one. Okay, so needing to turn -2 degrees Fahrenheit into Celsius. So I need a Celsius equals, and then just using the formula we came up with, 0.556, and Fahrenheit minus 32. So substituting in for my Fahrenheit. Right, now let's take a look here. I need to do my brackets first. So inside my brackets, I have -2 minus 32. If we think about what that answer will be, I have a -2 and I'm going down another 32. So it's like I'm at -2 and it's getting 32 degrees colder. So I end up at -34. So 0.556 times -34. And then you do that calculation and you get 18.904. One of the most common mistakes that I'll see here is forgetting to have your negative in there. So remember, positive times a negative, you are going to get a negative answer. Okay. And then just rounding to 1 decimal place, 18.9 degrees Celsius, negative. Okay, so -2 Fahrenheit is -18.9, so almost -19 degrees Celsius. Last one. While visiting Florida, Kathy heard a local person say that it was really cold as it was only 42 degrees. She's like, well, that's not very cold. And oh, it's Fahrenheit scale because I'm in Florida. So what is that actually? So I'm more comfortable with Celsius. What is 42 degrees Fahrenheit? So I can kind of know what that temperature actually was. So I need to find, if this is in Fahrenheit, because I'm in Florida, what is it in Celsius? So I need a Celsius equals formula. And I am going to use the one with the fraction. So Celsius equals 5/9, and then Fahrenheit minus 32. So 5/9, then in brackets, Fahrenheit minus 32. So it was 42 degrees Fahrenheit, so just substituting that in. So 5/9, 42 minus 32. Remember brackets first, so 42 minus 32 is just 10. Okay, and then 5 divided by 9, I get that 0.5555 number times 10. I get 5.555 repeating. And just cutting that off at 1 decimal place, take a peek over the wall, I'm going to have to round that 5 up. So it'll be 5.6 degrees Celsius. So yeah, a little bit cold. You wouldn't really want to be out in that for very long. All right, so your assignment, 4.1 temperature, and you're good to go.